Okay, so we're going to review for the college algebra final, and the review sheet that I posted is the review sheet that we give whenever we are going to take the 33 question college algebra final exam that has like everything from the whole semester on it. But since this is a weird time and I'm trying to make it a lot nicer for you, this is only 20 questions, and these are the topics that are covered. We deal with equations, 4 different types. Inequalities, only 2 different types, so no rational or quadratic inequalities. We are graphing a couple of things. 3 of the questions are graphs. And then we have 2 systems of linear equations, which I said was chapter 5.1, and we were going to talk about it later, which now is the time. And then we're going to deal with equation of a line, and then both of these are for functions, domain of a function, and how to find an inverse of a function. All right, so the first page is all just formulas you need to know and very helpful to have printed off whenever you're ready to take the final exam. And number 1 starts in on graphing a line. So we have a line 2x minus 3y, and it is in general form. So you can do a couple of things with this. You could rewrite this so that it's in slope-intercept form by getting y all by itself, or you can use some of the formulas that are on that first page where it says, nope, it's not on there. Oh, okay, that's fine. You could do that, or you can find the intercepts to graph it. I like the intercept method for this. So intercepts, you're going to plug in 0 for one of the variables, in case you've forgotten that. So when we do intercepts, we'll have 2 times 0 minus 3y equal to 6 as an equation. And then we'll also have 2x minus 3 times 0 equal to 6. And those, I just picked one letter to plug in 0, and then I picked the other letter to plug in 0 for the second equation. So we've got 2 different things. That's going to leave you with negative 3y equal to 6, and that's going to be negative 2. Here that goes away, and it leaves you with 2x equal to 6, and then when you divide by 2, you get x equal to 3. So when we graph this, we're going to pick negative 2 on the y-axis, 1, 2, down, and then pick positive 3 on the x-axis, 1, 2, 3, boom, and then we're going to draw a line through it. And that's the answer you're looking for. Bless me. Sorry. All right, so this is just one way to find a line. If you don't see the pictures in the answer choices, you should tell me the slope and the y-intercept, or you can tell me the x-intercept and the y-intercept, and that would be fine too. Okay, so just in a message, tell me that. But hopefully you see the picture answer choices. I mean, it should work. I don't know why it didn't work for that one student, but all right. Now we're going to do equation of a line, and number 2 and 3 are very similar to what you'll see for one of the questions. So they give you 2 points, negative 10, negative 1, negative 4, negative 7, and they say find a line that goes through them. So the first thing is slope, and the slope equation is y2 minus y1 over x2 minus x1. So this is x1, this is y1, this is x2, this is y2, and so we're going to plug in our numbers. Negative 7 minus negative 1, right? Negative 4 minus negative 10. And minuses become plus. So negative 7 plus 1 is negative 6. Different sign, subtract. Negative 4 plus 10 is positive 6. Larger number keeps the sign for both. And then divide, we get negative 1. That's the slope. Then we're going to use the point slope form, which is y minus y1 equal to m times x minus x1, right? So this is that, and then we do this. So we're going to plug in y1, which is negative 1, plug in our slope, which is negative 1, and then plug in our x1, which is negative 10. And again, we got minuses are plus, minuses are plus. So this is really y plus 1 equal to negative 1 times x plus 10. All right, and then if you want it in slope-intercept form, which I believe all the answers are in slope-intercept form, then we're going to distribute We get negative x minus 10. And then we're going to subtract 1 to get y by itself. And then finally, our answer will be negative x minus 11, like so. Okay. Number 3 is another one just like it, except different numbers. You know, good practice. Negative 6, 5, 3, 5. So again, slope y2 minus y1. This is, we'll label x1, y1, x2, y2. And I get 5 minus 5 over 3 minus negative 6. Well, that's 0 over 9, which is 0. And the only equation that has a slope of 0 are horizontal line. If it was undefined, if 0 had been in the denominator, it would have been a vertical line. But with a horizontal line, it looks like this. And if I'm going to graph that guy, oh, I'm going to write the equation of a line, sorry. Horizontals are always y equal to number. Now you can use the point slope form for that as well. You can say y minus 5 equal to 0 times doesn't matter because all this is going to go to 0. So you get y minus 5 equal to 0 when you plug it into point slope form, and that will become y equal to 5, right? So it's just another way to do that. So the other type of question that you might see with this, that you will see, sorry, is number 5 and number 6. I'm going to skip to number 5. So we got a point 6 common negative 4, and it's perpendicular, which is what that symbol means, to y equal to 3x plus 8. So because this is in slope-intercept form, their slope is 3. And so our slope is, because it's perpendicular, we're going to flip that to 1 over 3, and then we're going to change it to negative. So it was positive, now it's negative. So we always flip and change to negative for perpendicular. If it were parallel, it would just be the exact same number. So now we have a slope and we have a point. We can use a point slope form, y minus negative 4 equal to negative 1/3 times x minus 6. Right? This is my x1 and y1, right? That means plus. I'm going to distribute. And the negative 1/3 times negative 6 is going to be positive 6/3, which is 2. And then I've got to subtract 4. And I'll get y equal to negative 1/3 x minus 2 as the answer. Okay? So that's how you do writing an equation of a line. This one and this one are very similar to the ones you see on the exam. This is just another practice one. And yeah, number 6 is another practice one you can do, but I kind of want to keep this short. Let's cross off things we talked about. We've done graphing lines, and we've done equation of a line. All right? All right, solve for x in a system of equations. So 7 through 10 are very similar to 2 of the questions that are on the final. So let's look at those. We have negative 3x minus 4y equal to 25. And then we have x equal to 8y plus 1. So this is set up to be a substitution problem. So we have little old x equal to a bunch of stuff, and this stuff can be plugged in for x here. So that would create a new equation that instead of negative 3x, we have negative 3 times 8y plus 1 in parentheses. And then the rest, minus 4y equal to 25. Okay? So this is the idea of whenever you have a letter all by itself equal to something, take it and plug it into the other equation for that letter. And then you just little distributive property, do. Right, everything else the same. And then with little combined like terms, do. There you go. And then we're going to solve for y. So add 3 to both sides. Negative 28y equal to 28. And then divide, and we get negative 1. That's just one of the answers. So there's an x and a y, and it's a pair. So I need to take this number and I need to plug it in for y, negative 1 plus 1. See right here, and that will give me the other answer. Negative 8 plus 1 is 7, negative 7. Larger number keeps the sign, right? All right, so I'm going to put them together. -7 is first because he's x, and then -1 is y, and that is the answer for number 7. Solving a system of linear equations where one of them is all by himself. Number 9 is very similar to this, so if you want extra practice, you do number 9. Number 8 is the other type where you have both equations have the letters on the same side. All right. So for this one, x and y are on the same side, x and y are on the same side. So I just need to do something. This is something where we call, what is it called? The elimination method, I think, in your book. There's another word for it, the addition method. I don't know what's better. In this case, what we're going to do is we're going to multiply x by something, and then multiply this x by something else so that they end up being opposites. What I mean by this is that if I multiply this guy by 3 and I multiply by this guy by 2, then what happens is I'll have -6x, and down here I'll have +6x. Now they're opposites. That's what I want to create. And you could do this for y as well. You could have multiplied this guy by 2 and this guy by 7. It would work out as both 14y and -14y, and that would work as well. But I'm doing this. Now the thing is, whenever I multiply one term by a number, I have to multiply the rest of it by that same number in order for me to have the equivalent equation. So this becomes plus 21y, and this becomes -12. And then same thing down here. I multiply by 2, so I need to multiply by 2, multiply by 2, and that will give me -4y, and that will give me -22. Okay, so I looked at one letter, x, and I said, how do I make them opposites? Well, I multiplied this guy by 3, this guy by 2, and they'll both be 6. One will be negative, one will be positive. Bing, right, bing. And then the rest of them, I multiply by the same number in the full equation, and I get this. Now, I'm going to combine like terms. These two cancel. That's the point. 21 minus 4 is 17y. And then these two add, because they're both negative, to give me -34. Conveniently, 17 goes into that 2 times. So the answer y equal to -2 is just one of the numbers that is my answer. The other number, I'm going to have to plug back into one of these, and it doesn't matter which one. So I'm going to put a little star next to the one I am plugging it into. 3x minus 2 times -2 equal to -11. The original equation, because it's smaller numbers. And also, this is the equation that I haven't done anything to. I might have screwed up here, and if I plug it into here, I'll probably get the right answer, but I also might have screwed up, and then I'll screw up again. But here, if I do this and I do it correctly, I'll get the right answer. All right, so -2 times -2 is +4. Subtract 4 to both sides, and I get -15. Oh, hey, 3 goes into that. -5 times. So my answer here, -5, -2. Okay. So this is the 2 different methods of solving systems of linear equations. If you look at number 10, that's another problem where you get to do that. More practice for you. All right, so back to here. We've done systems of linear equations. We do. All right, sketch the parabola. Let's look at number 11. So sketching the parabola, if I have a quadratic equation in general form, x squared plus bx plus c, or ax squared plus bx plus c, then I need to figure out what the vertex is. So that's how I can graph this guy, vertex. And that is a formula on that first page, x is equal to -b over 2a. With this formula, I can plug in b and a, which is 1. I don't need c. And I get -6 over 2 times 1. And that's +6, and 6 divided by 2 is 3. So my x is equal to 3 for my vertex. But there's a y that I have to figure out as well, because it's a point, right? X, y. So the way I figure that out is I plug it back into here, the original problem. So 3 squared minus 6 times 3 plus 11. And that's going to be equal to 9 minus 18 plus 11. These two become negative 9 plus 11, and that's positive 2, large number. So my vertex is 3 for x and 2 for y. All right? And the only other thing is A. A is positive 1, and that means it opens up. So when I pick the correct graph here, I'm looking for a vertex that is at 3, 2, like this. And I'm looking for a parabola that opens up like this. Okay? And that's the extent of what you have to look for on the final exam for these questions, for those 2 questions. Let's do number 13 as well, just to get that practice in. 13 is h of x. It's got a new name. He's just the same thing as f. Doesn't matter. All right, so here we have a, b, and c, and I like to label it a, b, c. So my vertex, I say x is equal to negative b, so negative negative 6, over 2 times negative 3, which is a. Right? So that's positive. Positive 6 over negative 6, and that gives me negative 1. To find the y, I plug it back in, so negative 3 times negative 1 squared minus 6 times negative 1 minus 5. Little order of operations says do this first. That's positive 1 now. And then do the multiply next, negative 3, positive 6, minus 5. And then we're going to add, subtract. So this is positive 3. 3 minus 5 is negative 2. Sorry if I did all that at the same time. You know, I'm trying to do this a little faster. So we get negative 1 for my x and negative 2 for my y. If I'm picking the right graph, I go left 1 and down 2 to find my vertex. And then I look at A, and A is negative 3. That means that it's opening downward. And the 3 actually is squishing it a bit, but you don't have to know that. Okay, that's how you do those. Graphing parabolas, done. Okay. We don't have to rationalize. We do have to find the inverse and do domain. However, where are the domain questions? Holy smokes. I don't see any domain questions. Oh wait, no, there they are. 30 through 35. So okay, yeah, we got both. So let's go in order of the sheet. We're looking at 16, I guess. No, you know what? Let's do 17. I think that's most like what you'll see on the final. Hint, hint. This is just a function with the 5th root on x minus 3. So that in order to do inverse, we can do it one of 2 ways. We can pretend this is y. We can rewrite y. And then we could just swap them, x instead of y, and then y instead of x, like so. So we just swapped the x and y, didn't do anything else, and now I just want to solve for this new y. So I got to get rid of this 5th root, so I'm going to raise to the 5th on both sides. X to the 5th equal to y minus 3. And then I'm going to add 3 to both sides, and I'm going to get x to the 5th plus 3 equal to y. And that is your inverse function. So that's just one way to do it. The other way is to write out in words, step by step, according to the order of operations, what you're doing to x. So I would say, number 1, subtract 3, number 2, 5th root. And then when I write the inverse, I'm just going to go in opposite order with the opposite of each one of those things. So instead of 5th root, I'm going to raise to the 5th. And then instead of subtract 3, I'm going to add 3 in that order. It's just 2 different ways. All right. Jumping down to, we're not doing composites on the final. And we're not dealing with rationals. Yay. So we jump down to number 30, 31 through 35. And I'm going to do 32 and 34, which are more like what you'll see. So f of x is equal to the square root of 8 minus 2x, and you're asked to find the domain. The domain for radicals, you set whatever's underneath greater than or equal to 0. And this kind of leads us into our inequalities that we'll have to look at. So here we're going to solve it, and we're going to subtract 8, both sides. Yeah? And then we divide by -2. We're going to flip this inequality sign to get +4. Right? Less than 4. So when we're talking about the domain here, if we graph it along the number line 4 somewhere over here, this is a left pointing arrow with a bracket. And over here is -infinity. So this is me graphing x less than equal to 4. And then me writing in interval notation the answer, because that's what you have to do, would look like this. Cool. Okay. I thought I would have more room. I could have. I just did not think ahead. So let's go to the next page for number 34. Number 34, we have f of x, and that is equal to x minus 3 on top, and x squared plus 4x minus 12 on the bottom. So when we find the domain with fractions, we do a different thing. We say whatever the bottom is, not equal to 0. And the reason why we say not equal to 0 is because we can't divide by 0, right? Anyway, what about x minus 3? I don't care. I don't care. IDC, for those of you who like to, speak in text form. Sorry. All right, so we're going to factor this because it's a quadratic equation, which we are going to have to talk about in a minute. One way to solve them is by factoring. And if I factor this guy, I can say what two numbers multiply to give me 12 and subtract to give me 4. That's 6 and 2. But +4, so I have to have 6 and -2. Yeah, like so. And then I set both of them not equal to 0, sorry. It's the same thing, but it's not the same thing, So we get x is not equal to -6, and x is not equal to 2. These are the two no-no numbers. But I want interval notation. So let's put -6 up here and 2 up here, and look and see what this looks like. So if it's not this, it's everywhere to the left of it. If it's not this, it's everywhere to the right of it. And it's all this stuff in between. Like, all of this is good. So you might be like, wait, it's the whole line then. See, it can't be -6, so I put a parentheses here. And it can't be 2, so I put a parentheses here. So I have 3 different intervals all kind of pushed up against each other, but with little space. So, this is -infinity, this is +infinity. So I'm going to write -infinity to -6. And I'm going to write -6 to +2. And then I'm going to write +2 to +infinity, like so. All parentheses, and then we're going to connect them with little u's, just to say, hey, there's a little space there. All right, that's how we find the domain with this type of problem. So, domain and inverse, done. Boop. Now, we have simplify using exponents, properties. We don't have any of those, so we're going to skip them. We have use the properties of logarithms. I didn't put any logs on here because, that was the last thing you learned. You learned it under quarantine, so I was like, maybe you shouldn't test it. Anyway, now we're getting to we're going to solve equations and solve inequalities. Where are we at, 23 minutes? I'm going to do that as a part 2.